Hi, today we learn about common Laplace transform pairs and some examples of Laplace transform and Dirac delta function. So common Laplace transform pairs. Here we can see some unit level impulse, unit step, unit ramp, parabola, in exponential, asymptotic exponential, dual exponential function and their definition and their Laplace transforms. Their Laplace domain functions are like this. So after Laplace transform of delta t, it converts to 1. Okay, like this we can get through the Laplace transform. So we will now see some examples of Laplace transform. You can get the f of t equals to et if you Laplace transform this function, you can get f of s. So how we'll get this? We can get here if we go through this. So 0 e to the power t to the power minus st dt. Okay, now integration of e to the power t minus st. We can get this from there, that. Okay, now what we will do? We will just take common t. We can do taking common t. So after taking common t, it will be 1 minus s. So here, this is 1 by t, 1 minus s into t. We have got this. So now, if we do integration, we will get 1 by 1 minus s e to the power 1 minus s into t. And after putting the limits, we can get 1 by s minus 1. So now we will do the example of Laplace transform. Another example, Laplace transform of 3 delta t minus 2et. So we'll just separate these two functions and then we'll just apply Laplace transform delta t. So Laplace transform delta t, from this we can get that Laplace transform delta t is 1. So we'll just put here 3 into 1 and Laplace transform of et we'll get from this that 1 divided by s minus 1. So we'll just put here 2 divided by s minus 1 and we'll just do the subtraction. So have we can get 3, if we subtract 3 minus 2 divided by s minus 1, we will get 3s minus 3 minus 2 divided by s minus 1. So we can get 3s minus 5 divided by s minus 1. Okay. Now this problem is solved. Now Dirac delta function. What is Dirac delta function? In mathematics, the Dirac delta function is a generalized function or distribution. It is used to model the density of an idealized point mass or point charge as a function equal to 0 everywhere except for 0, and whose integral over the entire real line is equal to infinity. Equal to 1, sorry, it's not infinity. Okay, as a distribution, the Dirac delta function is a linear functional that maps every function to its value at 0. So the Dirac delta function can be loosely thought of a function on the real line which is 0 everywhere except at the origin where it is infinite. Delta of x equals to plus infinite when x equals to 0, and delta of x equals to 0 when x is not equals to 0, and which is also constrained to satisfy the identity integration of delta of x dx equals to 1. So from this line you can get whose integral over the entire real line is equal to 0. So the integral equal to 1, sorry, it's equals to 1. So we can get this 1. Okay, thank you. This all for today.